This is the Prinztronic Financial, an unusual calculator. Prinztronic is the normal brand, it's Dixon's brand on the 70s, but the Financial is not the most common one. It uses 4 AA batteries, and this particular exemplar is in superb conditions. The back has no scratches, the sides as well, and the calculator is pristine, is really in good conditions. So let's turn it on and see how it's working. It's a green vacuum fluorescent display. Let's check if all the segments are working, and also the negative sign here. So this is good. All the keys. So every key is working as it should. Basic operations. 3 plus 2, 5, times 6, 30, minus 80, 50 minus, and divided by 2, 25. So working as expected. And these are the basic functions of these keys. The percentage works as one would expect: 200 plus 10%, 220, and there you go. So up to this point, a very normal calculator. Things that are interesting, apart from the financial elements and that are not particularly common from HP, Texas Instrument, that would be the options. And this is really on the mass market. The first thing is that it's fixed as 2 decimal points for the separator. So even though you have space here, it will stick to 3.33. And even if you enter longer numbers with more decimal places, when you invoke the operation, it will round off for 2 digits, which is what you would expect for money. So in the sense, a very unique, peculiar calculator, and you don't have options to change this. It's really optimized because there are very few keys and a lot of functions, so the number keys are also used for the functions. The syntax is quite curious because you have this enter and this compute, and the enter is for the functions, but the compute is also for the functions. So the core ones are these here, where you can calculate loans or mortgages and this sort of things. So I'll turn it off and on. So let's start with the present value of 0. So we don't have any money in the saving account. We put £100 every month as the payment. We will do that over 12 months, the number of months, and we'll have an interest rate of 1% a month. With this, so we have interest rate, we have the time, the monthly payment, and the present value. We can compute the future value, and this will give us 1,268. So just the 12 payments of 100 would give us the 1,200, and the 68.25 is the interest rate that is compound month by month in this case. So this would be an example of a saving account. Let's do a different example where instead of calculating the future value, we would like calculate the present value. So let's do the case of a mortgage simulation. So we start by setting as 0 the future value. So at the end of the mortgage, we paid it all. We'll set an interest rate per year of 5%, so you're using the annual interest rate. We set the number of months as 360, so 30 years, always entering and end the number of months. And our monthly payment, let's set as £1,000. As we are paying that, I will make this negative, and now that we have this, we will enter this as the monthly payment. With interest rate, number of months, monthly payment, and the final value 0, we can ask it to compute what's the present value of this calculation. And this will be 186,000. So that's the amount of money that we can borrow, and we will be able to repay using this inputs. So before Excel, this would be a quite complicated calculation. We would need to do that month by month. And here, a couple of seconds, we got this calculation. So in this case here, with any given scenario, you can calculate either the monthly payment, or in this case, the present value, the future value, so the two that we did. If you want to calculate the monthly payment, for example, let's just do a simulation. So let's get the 186,000. So let's suppose that so let's consider the case where we don't know the monthly payment. We know that, and we always start with the future value. In the future, we want to owe 0 to the bank, and we are borrowing 186,000 from the bank now. So we are negative 186,000, and this is our present value. We have a 5% annual interest rate, and we have 30 years of mortgage. Under these conditions, the only thing that we don't know is the monthly payment. So we ask to compute the monthly payment, and there we go. It's roughly 1,000 because we rounded the mortgage value, but we pay £1,000 a month, and with this we will be able to repay this loan. You always start with the future value when you're imputing this, otherwise it doesn't work properly. But this shows this area here, which is the core part of the calculator, the most interesting part. You have as well square root, nothing remarkable on that. So 25, enter square root 5, takes a second. We have the relative percentage, and the syntax is a bit curious. So the relative percentage, let's suppose that we have 80, enter. And once you press enter, it will wait for one of these keys. So it's not any key that will register the 80 as the first number. Usually the interest rates usually work, but this one is the one that we use to enter several values. It's a safe choice. So it shows that you enter the first value. And then we can say 100 and calculate the relative percentage of 80 to 100. Which is 25%, because 100 is 25% more than 80%. So very curious syntax that the calculation has in terms of inputting numbers. The sell and cost and margin are very similar in a sense. So let's suppose that we have again 80 as the cost of your whatever product, stock, and so on. And then you have 100 as the selling price. And if you want to calculate the margin, say compute the margin, and it's going to give you 20%. In this case is one relative to the other, from the 100 to the 80. So 80 is 100, 80 is 20% less than 100. So very similar functions here and here with different aspects, but not that useful, nothing compared to the complexity and the usefulness of the present value calculation. You have here a sum value that I really couldn't figure how to use, neither the DS, but the average is quite interesting. So you can enter several numbers. So let's suppose 2, enter, and you store it using the TL, which is the first number. 5, enter, and the TL shows that there's a second number, and 7, and the TL is a third number. So we have 3 numbers now, and if we ask to compute the average, it calculates the average of the 3 entries. In principle, what I would expect is that by saying compute and press this one, it would give us the sum of the 3, but no, it takes as the enter of a 4th number, which doesn't make a lot of sense. The other thing that it doesn't make much sense is this trend. The equation seems to be something like the multiplication between 1 and the first number, 2 and the second number, 3 and the third number, all added up, plus 3 numbers times the sum of all the numbers that we entered, which does not have a lot of sense, and usefulness is not something that you can use to calculate the slope of a line and so on. If we ask here, for example, to compute the trend, let's do it again. So 2, enter first number, 3, enter second number, and 8, enter third number. And you have to compute the trend, we get 71, which is doesn't make any no, it does make any sense. It makes the sense of the calculation that is being done, which is this product of the position and the value plus the number of entries times the sum of all the values. And that's what's being done. But the usefulness of this is debatable. So here, not that useful. Here, not that useful. The average, somehow interesting. Again, something that you would be able to do by hand in a sense, because it's just adding numbers up and dividing by the total number of entries. So not particularly useful. Percentage as well. But these ones here would be quite unique in terms of calculating savings or loans and this sort of things in different scenarios, and very flexible. The color scheme is typical of the Prinztronic, and the state of the calculation is really, really beautiful and unique. And this is the Prinztronic Financial.